Standards identified in these activities have been adopted from the content standards of the national organization for each discipline. More information on this can be found in the Technology as Facilitator of Quality Education model. The students in this 9th grade algebra class are learning about the factored form of quadratic equations. The teacher gives the students a worksheet that will help them discover the factored form. The students use TI-83 graphing calculators along with paper and pencil to complete the worksheet. The teacher addresses Technology Performance Indicator number 8 for grades 9 through 12, which requires that students apply technology tools for problem solving in content learning.
Go back to your y equals.
Graphs?
Is it x squared plus x minus 20?
X squared minus x.
Is it minus x or plus x?
Minus x.
Okay, that might make a difference.
I got a very large graph.
Yeah, so did I.
I don't know where
You can't even sketch it if you do it in the Zoom.
Yeah, you do. You just make a little line like this right here.
Does it still? Is it in there?
See that little right line?
Okay, it doesn't.
See that line right there?
Is it over there?
Yeah, you draw that little line there, then you draw that little line there.
The teacher discusses the worksheet with the students after everyone has finished. The problems on the worksheet help the students discover the connection between parabolas and the factored form of a quadratic equation. The students also learn how the factored form relates to the vertex form and the general form. This learning activity incorporates mathematics standard number 2, which requires that students understand patterns, relations, and functions in algebra.
We started off class looking at the general form and then the vertex form, and you were supposed to come up with the factored form. Which group would like to share that with us right now? Taylor, go ahead.
A parentheses x minus r1.
What does R1 mean?
The root, the first root.
The first root?
And then in parentheses x minus r2.
Can you explain why it's minus?
Because it's the opposite of the roots.
It's the opposite of the roots. As I walked around, all of you were telling me that that's what you noticed. That was the pattern that you discovered, that all the x-intercepts, those values were opposite of the values you put in when you factored it. Okay, and that was important to discover. Number 6, I asked you to apply what you learned here. You were given the x-intercepts, so you should have the general form. Actually, you probably did the factored form first, didn't you? That was the first thing you did. You wrote x plus 4 and then x minus 5. And then you probably figured out the general form. Who can tell me how you go from the factored form, from the one on the right, to the one on the left? How do you do that? Go from the factored form. Melissa?
You just multiply it.
How do you multiply it?
Like x times x equals x squared. And then x times 5 equals 5.
Based, yes, exactly. It's a product of binomials. You just multiply that out. So it would be x squared minus x minus 20. And then you should have your sketch of your graph.
The students have to apply their new knowledge to a real-world problem. They adapt and apply mathematical concepts and strategies they have learned to find a solution. The teacher incorporates mathematics standard number 6, which requires that students use mathematics in problem solving.
We are going to apply what we just learned. We are going to answer this problem. And it says, suppose you have 24 meters of fencing material, and you want to use it to enclose a rectangular space for your garden. Naturally, you want to have the largest possible area for your plants. What dimensions should you use for the garden? Okay, so you are seeing some patterns here. As the width increases by 1, the length decreases by 1. Go ahead and draw the next 5 gardens for me then. You can fill in your table for the next 5. What about the areas of these? How do you find the area? Who can tell me? Oh, you all know how to do that. Multiply? Okay, so let's fill in the area column. It would be 0, width times length. 11.
20.
Okay, stop. Stop. Let's look at something. Increasing, increasing, increasing. Will it continue to increase?
Yes.
All right, 8 and 4s, 32. Then we have 35.
36.
Then we have 36. Oh, and then we have 35 again. Then we have 32. Okay, do you see this right here? Is what we call our maximum area. And the dimensions would be 6 by 6.
The teacher has the students look at their solution graphically. This helps the students see the connection between the problem they solved and the concepts they have been studying. The teacher integrates Mathematics Standard Number 9, which requires that students understand how mathematical ideas interconnect and build on one another.
What is the real-world interpretation right now of x being 0, scroll down there to the left, and y being, nope, I can't, that's the best I can get. Who can tell me what that means right there? What's the interpretation of that? That's where you'd have the smallest area. Okay, right there. So what does this tell me about the problem I asked you? It says that if I have 24 meters of fencing, I should build my fence to be a 6 by 6 because that adds up to 24, and it would give me the largest area. It would give me the maximum point of 36. Okay? Okay, so now if I asked you to tell me the equation, if I have 420 feet of fencing, tell me, raise your hand, what the equation would be of the parabola that I would get if I graphed and I had 420, let's stick with meters, I said feet, 420 meters of fencing. Should be, raise your hand and tell me what I should type in. Kristen?
X minus 210 parentheses x.
Times x. Okay. Everybody understands that that comes from the roots. One root would be at 210, half the distance, and the other root would be at the origin.
The teacher addresses Mathematics Standard Number 9 by requiring the students to recognize and use connections among mathematical ideas. She extends the students' knowledge of the factored form through an experiment. The students use motion detectors called calculator-based rangers to find out how high they can jump. The experiment requires students to jump in front of the motion sensor while it measures the distance to the wall behind the jumper. Although the data collected is linear, the students will use a parabola to model the time the jumper leaves the ground to the time the feet return to the ground.
Now, here's what we're going to do to figure out your jump height, because this is measuring distance versus time. It's not measuring the height of your jump. There's a physics formula, and it comes from Newton's law of motion that is going to be on this handout that I give you. It's based on the force of gravity. It's an equation, and the equation is in the factored form. Okay? And what we're going to do is we're going to place a parabola, so to speak, on these peaks. Because the parabola, if I'm able to put a parabola here and here, what will the x-intercepts of that parabola tell me? The time. And the formula requires you to fill in the time. Fill it in for root 1 and for root 2. And then do all the math, and then the y value that's going to result is your jump height.
This activity also addresses Technology Performance Indicator Number 8 for grades 9 through 12, which requires that students apply technology tools for problem solving in content learning.
Who has calculated some jump heights already? We have. Okay, will someone in this group come over and explain to this group here how you're getting those values?
Do you have to solve it then? Technical numbers and stuff. I'm not gonna
Okay, what do you want?
They don't know what to do with those numbers.
I know. I kind of do, but do we have to solve it then? Like,
Okay.
to make it equal to 0?
You put negative 192 in your y equals.
And then, okay,
Negative 192.
right.
In parentheses x, because you don't have a t variable on there.
Oh, so I just
Minus your first time, which is time left.
10
Then you put the two parentheses in, and x minus the second
Just
time,
testing,
which is
yeah.
your landing time. Then you get your parabola.
Oh, and then we find that. Okay, I get it.
Then you find what, Holly?
The maximum or whatever, right?
Why?
Yes.
Because that tells you how high you jump.
The teacher assesses the students' learning by having them interpret two graphs that model the same kind of data the students collected in their experiment. The teacher again integrates Mathematics Standard Number 9 by requiring the students to recognize and use connections among mathematical ideas. She also integrates mathematics standard number 6 by requiring the students to solve problems by applying and adapting mathematical concepts and strategies they have learned.
Here's how I'm going to assess how well you understand what we did. We have two people jumping up here, Al and Allison, and we've got some information that's listed there for you. I would like you to tell me something about these two people. Okay? You also need to tell me something about when they took off, when they returned, what's the difference between their plateaus at the top. Tell me a story about these two people. Who can tell me the real-world interpretation of x equals 4.397? What does that refer to? X equals 4.397. Holly?
That's the time we started the jump.
That's the time it took off. X is time, right? Okay, Ryan, what's Y? The distance from the motion detector. She started further away at 0.534. All right, when did she take off jumping? So I could ask, who jumped earlier when the CBR started? She jumped faster after 1.29 seconds. Okay, she landed 3.98 seconds later. What was her jump height?
345 centimeters.
345. We're still doing inches. 345 inches. Okay, now I put that up there for a reason. What must have Allison had to do in real life?
She stepped away.
Just step like this way.
She jumped like
She could have jumped out away from it and then jumped in. That would be good. One thing she could have done. What else could have she done?
Held, like jumped onto something.
She could have grabbed up onto the lights up there, hung up there, and then landed. What else could have she done? She could have maybe jumped onto a chair and then jumped back from the chair off.